Welcome to my channel Dr. Munshi Nasser Scale Tone. In the previous video we are covering the book using R for Introductory Econometrics. Then this is chapter 2 we are going to cover by Florian Hayes, and as I told you that this is the Aldrich Introductory Econometrics book that we are going to cover as a theoretical concept, and the application that we are covering using this Florian Hayes book, and we are using R programming for our application and understanding. So let's get started. So in the last video we have calculated the simple linear regression model, and as well as we calculated how to manually calculate the OLS regression, the beta intercept and the coefficient value. Now we are going to use some couple of example, like for example last time we have used the CEO salary and return, okay, and if we would like to make a graph, I mean the regression line that we are talking about, so we can use this simple command. So let's assume that we are making a new CEO regress as our object name, and then using the R syntax, then the function command lm, the simple function linear model command for R. So we are going to cover the one that we already see. Your regress is our object, lm is our function, linear regression function, and salary, and then our independent variable ROE, and this time we did not attach the data. So therefore what we are doing is we are using our data is equal to what we are using, CEO. It's already coming, recommended by our studio. So now we already created this command by control enter. We already created this command, I mean the command is executed already. Now we are going, our main purpose is to find out the scatter plot is restricted by y-axis limits. So if we can use the scatter plot, so we can use a with command, which means this data set that we are using, CEO cell 1, this data set, and then the plot command. This is the function of the plot command, so ROE comma, and then what we are going to do is using salary as our dependent variable. We are using a correlation analysis, so we are using and limiting the value because we have a bunch of a huge number of data, so we are limit the value, and that's what we are using y limit, which means the dependent variable limited, using our concatenate function c from 0 to 4000 only. So it's from 0 comma to 4000, okay, and that's end of our command. Okay, so if we just control enter, and if we look at the value here, okay, this is what it says, salary in the y-axis and ROE is the x-axis, and this is what we have our command of the correlation between the two variables, dependent and independent variable. Now what we are going to do is we are using the regression line, which is our estimated line. And how can we do it? Add the OLS regression line, which is our estimated line, and the line is every line. This is estimated line command, estimated line command of our this regression that we have covered, this regression, lm regression, this is the command that we have covered. So this is the object that we are putting for our regression line. So CEO regress is our command, and then let's see how does it how does it look like. Okay, so it's supposed to come like this, okay, and this is the value. Okay, I'm pretty sure there's something wrong. Now it comes. Okay, so you see that this is the line, the regression line, this is the regression line, and the value is scattered, but most of the values are very close to the estimated line. So it's a pretty good regression analysis because the estimated values, the estimated line and the values, the observed values are very close to this estimated line, and few of the values are here and there, but most of them are clustered in the line that we have created using the regression command. And one more thing you need to remember, that the distance between, from, let's assume that from this line to this point, this is the distance we actually find by calculating the error term. Error term is the difference between what we actually find and what is our estimated value. So basically this is the estimated line and this is the actual observation. So difference between these two distance is our error term, and that's what we will do in the later part of our video today. So basically I hope you understand the very simple way of doing the thing that we are looking at, right? And this is what it says in the regression line, and this is, you see, this is the same thing we have covered using the R programming. And now there is another example. I want you to do it by yourself, this analysis using this data set called the wage.dta data set, and we are interested in studying the relationship between education and wage. These are the two variables, univariate regression analysis. I want you to do it by yourself using this book example. I already shared the link, my Google Drive link. You can go and find out this book and download the R Studio and practice with me by using this video, as well as you can practice it by your own way. I mean, here we are understanding the main concept of doing the same things. Okay, so basically here it says the dependent variable is wage, and our beta naught is our intercept, beta 1 is our coefficient education, and this is the our error term, and this is what we are going to find from the regression line. And the command we are using, simple linear regression function. Wage is our dependent variable and education is our independent variable, and we are attaching data wage 1, and this is what we have found from our analysis. And I want you to do it by yourself. And there are another example, voting outcomes and campaign expenditures. So this is one also you can do it by yourself, and here also the scatter plot, same command we use with vote data, plot these two variable and then align by regression line. Okay, the same process that we have covered just now using the same example. So I want you to do these two examples for your practice. Now the final part of this video is the coefficients, fitted values and residuals. Okay, coefficient, fitted values and residuals. As you can see, the object returned from the LM function contains all relevant information on the regression. So normally in the Stata or any other software you find that, or reviews, that the bunch of information already come up, right? Same goes to come in the R programming. If you give a summary command, the command will also give you everything. So basically this is what it says, that the name of regression command. So if let's say we are going to see what are the information that is inside this CEO object regression, if we would like to see that. So now this coefficient, under the names we have found that coefficient, effects, fitted values, X levels, terms, residuals, so many things. Okay, and if we'd like to go and find, let's say if I want to find the coefficients, or if we want to find the residuals, all we have to do, just give a command CEO, which is the object that we have created by linear regression command, this one. Okay, and give a call sign, which is the dollar sign. Dollar sign is you are calling the variable. Okay, so in this object, these are the information already inside it when you run any regression. So giving the dollar sign command, meaning that you are using the object and calling the inside the information that is inside the command. So basically we are calculating the coefficients, so we just create coefficient, control enter, and you see the value 963 and 8.50. That's what it found from this particular case. So if you'd like to find more information, like for instance you would like to see CEO, okay, this is the object, and again you make the call command, and if you see the residuals, okay, and if you give the command and you see the residual list is already come. And residual, remember that I told you that the distance between the estimated line and the observed value, the difference between these two are your residual. So residual is the estimated line and how far is the observation from that estimated line, that is the residual, right? And that's what it says, and every single observation and its distance from the regression line is calculated by CEO residuals information. So this is how you can calculate it very easily. So last thing that we are going to cover in this lecture is the R square value. R square is nothing but the overall goodness of fit of the model. So basically it shows the dependent variable and the independent variable. What is the variability between these overall model? So basically in R square it says how good your model is. If the value close to 1, then meaning that the value is more or less a good model. If the value of R square close to 0, then you will find that this value of the model gives you the idea that this is not a very good model. So basically goodness of fit indicate that how good is your model, and in order to find that particular value you just need to calculate the R square, and the total sum of squares explains sum squares and residual sum of square, and you see the variance of the residual and the variance of your dependent variable, and this is what you can find from your estimated value. So variance of your estimated value and variance of your observed value, so difference between these two will give you the idea of R square, and R square is simply but the overall goodness of the fit model, the overall goodness of the fit. So overall goodness of the fit you can calculate using this manually. You can calculate the R square value, the one that we are sharing here, or either you can give the summary of R square value, which means that, for instance, if we take the same example, so let's say if we give a summary command and we go CEO regress and go this value, and you will see this underline of this value. It gives you all the information. Okay, it gives you the coefficient value, residuals value. Okay, it gives you the significant values. Okay, if also it also gives you the R squared value 0.013 and adjusted R square value is 0.0084. so what does it mean R squared 0.013, which means the model gives you only 13% goodness of fit, which in other words saying that this model is not a good fit. The regression dependent variable and the independent variable, these two value are explained only 13%, meaning that the rest of the information, almost 87% of the information, are not explained by the dependent variable and the independent variable that you have chosen. The rest of the information are explained by some other variables which you did not include in the model, and that's what it says. So only in this particular univariate model, when salary and the ROE, the rate of return, these two value, when we are calculating for regression analysis, only 13% are explained by these two variable to variability of the salary and the relationship between the ROE. R square, in other words, is the correlation value between R square salary and the ROE, or dependent and independent variable. But when we squared it, we are getting the information that how much of these two variable explain for the whole model. So in here we are looking at that the value is very small, close to 0, which is 13%, not close to 1, 0.013. So in this case 13% only explains. So 87% of the model is explained by some other variable which we did not include in the model. So in other words, we can say this is a poor fitted model or poor model. Adjusted R square is nothing but the considering the degrees of freedom. And degrees of freedom, if you look at the degrees of freedom, I have another video in my channel. Please look at the degrees of freedom video. It meaning that how many observations you can take independently. Okay, that is the degrees of freedom, and using the adjusted R square is more appropriate way, and it also gives you 0.0084, which means even lower value and very close to 0, which means the model that you fitted is not a good model or good fitted model. So therefore I strongly recommend you, by looking at the R square value, you can judge whether your model fit is good or not. And R square explain that these two variable, how much percentage of these two variables relationship explain the whole model, and in our example we can see that it's only 13%. So the rest of the 87% is not explained by these two variable, which means we need more variables to explain the whole model or scenario of salary, and explained by other variables, not only the ROE but other variables which we did not include but we need to include, because the reason that the model is poorly fitted with these only two variables, and that's what it says in R square. So I strongly recommend you to use the summary command or summary function and use the object where you put your regression, here the regression value, so that will gives you all the information that you need. And in here as well there's another example, of course, wage and salary, education and wage, and the same way it gives you the residuals, coefficients, R square value and everything. Okay, and I strongly recommend you to follow this particular way. And there are some other examples like non-linearity, and we are going to cover in the next video hopefully. And until then, I wish you a good stay, and I'll see you in the next tutorial discussing about the non-linearities assumption in OLS model. Thank you. Bye bye.